All right, good morning, guys. So what we're going to go over today is we're going to go over whether something is a function or not a function. And I have a couple of problems here, two with tables, two with relations, and two with graphs. All right, so whichever problem you're working on, you can just skip to the video or the parts that I'm working on that matches your type of problem if you need help with the assignment. All right, but I'm going to go a little bit quick. If you need to stop and go back or rewind or anything like that, you're free to do that with the video. All right, so let's get started. So we've got this one here, number 1. Now, if you're looking on a table and you want to figure out if it's a function or not a function, all you have to really do is look at the x column, right? So what you're looking for is whether a number is repeated or not. So I'll take a look. I have 0, I have 1, 2, and -2. Now you can see this 2 and this -2. Well, while they are 2's in a sense, these two are still different numbers because it's a negative. So in that case, yes, this is a function. So even though it's a -2 and a 2, and they look like they're the same number, they're still considered different numbers. It's only when they're the exact same number that it's not a function. And we'll see that in this one. Spoiler alert. So we've got, again, we're looking at the x column, this one right here. And we're looking for any repeats. So I've got the 6 and the -6. Just like I said in the last problem, this is completely fine. Absolutely fine. But if we go down here, I see a 2, 12, and a 2, 13. Well, I have 2 of the same number. That 2 is repeated. So in that case, that means it is not a function. So as soon as you see that repetition of a number on the x column, then it cannot be a function. If it's repeated in the y column, that is absolutely fine. It will stay a function. All right? So that is tables in a nutshell. Let's go on to these relations. Now, relations are actually the same thing as these tables. We just wrote them differently. Think of all of these right here, these parentheses, as coordinate points. So I can label all of them x comma y. This one's also x comma y. This is x comma y. So I can do that for all of those points right there. And then I'm doing the same thing. I'm looking at all my x values to see if they're repeated. If I want to, what I can do is I can make a little table myself. So with x and y. And then I'm going to write each of the coordinates on that table. So I have this 1, 2. So 1 and then 2 right there, like so. And then I can keep going. I've got this second coordinate, 3, 4. So I'll have 3 and 4 right there. And then the last one, 5, 6, same thing. 5, 6, right in that chart. And then I just treat it exactly like how I would with these earlier problems. So I'm just looking at my x column. I'll use a black marker for this one. And I'm looking for repeats. But we see here, 1's not repeated, 3's not repeated, 5's not repeating. So in that case, this must be a function. Awesome. And then we do the same thing for this one down here. So I can go ahead and make my chart. Might be a little small. That's fine. I've got 1, 2. Whoops, there's x, y. 1, 2, then 2, 3. And then 1, 4. So that's what you should see on that chart. And then just like before, looking at that x column, I'm seeing if any of my numbers got repeated. In this case, this 1 right here is repeated. So in this case, since I have a repeat in the x column, this cannot be a function. Not a function. So that is tables and relations. Now let's go on to graphs. Now graphs, you could do the same thing. You could do something very similar. You can plot points all over this graph and find the coordinates. But as you know, with graphs like this, there are an infinite number of points. So if we were to make a table that was infinitely long, it's probably going to take a long time to do. So we have to approach this a little bit differently, but not too differently. What I'm going to do is you can take any straight object, so I'll take my marker, and we're going to do what's called the vertical line test. And all you have to do, take your marker, your straight object, and plop it anywhere on the graph. Now you want to make sure it's going up and down though. That's what vertical means, right? Up and down. So I'm going to take this, I'm going to start on the left side of the graph. I'm going to move this marker to the right. And what I'm looking for is when does this marker hit the graph? So if I start over here and I go all the way over here, I see that my marker hits my graph right here. So if I keep going, I'm making sure that this marker hits my graph only one time every time. So if I'm over here, it only hits here. If I'm over here, it only hits here. And I can represent this with a bunch of vertical lines. So since you can see, all of these vertical lines will only touch my graph one time. Because of that, it is a function. So what does this have to do with these problems over here? How are these problems similar? Well, over here, I was looking at my charts, right? And I'm looking to see that my x's aren't repeated ever. This is the same idea. I'm just looking at it visually instead of on a table. So if my x's were not repeated, I shouldn't see two intersections per vertical line. That's just a little extra thing, just to find out the connections between these two. But let's go on to number 6. I'm going to do the same thing here. I'm going to take my marker, start on the left, make sure you're vertical, right? And you're going to move to the right. Now, I'm looking for when it hits the graph. So right here, it touches right here, but just one time so far. But if I keep moving over, I'm going to see that my marker actually hits the graph twice. Once up here and once down here. And it's hitting it at the same time. That means my x has been repeated. My input, my domain, has two elements that are the same. That cannot happen. We don't want this one. So I can keep going. I can keep saying that there are times when it hits the graph twice for these vertical lines. And since it hits twice, it cannot be a function. And that's what we saw in these charts before. So for number 2, I saw that I had 2 2's, right? This is the same thing. This is like saying I have 2 0s, I have 2 2's, I have 2 3's, right? And that's what you don't want in your x part of the chart. So that's pretty much it for the problems in terms of this assignment for today. If you have any questions, don't hesitate to contact me and let me know. And you guys have an awesome day.